Good morning, guys. So today we're gonna continue talking about solving inequalities. So we're gonna start out with a little bit of a review about what we did yesterday. So solve the inequality and graph on a number line. So I want you to solve this first one for x. So pause the video and come back when you are done. So when you solve this for x, it's a pretty simple one. We're just going to add 7 to both sides, and x is going to be less than 5. So when we graph this on a number line, our boundary point is at 5, and it's going to be an open circle because there's no equal to sign, and x is less than 5, so all of the numbers that are less than 5 is the direction of our arrow. Next one, it's a little bit different, so I want you to give it a try, pause the video, when you're done, come back and I'll walk you through this. So since we always want x to be on this left side, I want to get rid of the 8x. And when I get rid of that, 3 minus 8 is a negative 5x. Okay? And then we keep solving for x. And here is where we run into a little bit of an issue, because when we divide by a negative number on a number line, so if we think of just a general number line, it's going from an x value that's negative to an x value that's positive. So because it flips like that, we need to flip our sign. So every time we divide by a negative number, our inequality needs to flip direction. So it went from less than to greater than. Negative 10 divided by negative 5 is going to be a positive 2. So it doesn't matter if the numerator is negative. That works every time. But if we are dividing by a negative, that's when we have to flip the direction of our inequality. So when we put our closed circle at 2, our x's are going to be in the positive direction. So let's look at another one. We have a fraction this time. So we can solve this like regular. Okay, I'm going to get rid of that negative 2. And then to get rid of our fraction, we multiply everything by our numerator. So when I take 2/3 times 3, the 3's are going to cancel out, leaving us with 2x. And negative 2 times 3 is our negative 6. Then we can divide by 2. X is greater than negative 3. We can graph that on our number line. We're going to do open circle because there's no equal to sign at negative 3. And our x is greater than, so there's our direction of our arrow. And there we go. So let's try a couple more. So I want you, it's a little bit more complex, this inequality. I want you to pause the video, solve for x, come back, and check your work. So So on this one, my first step is going to be to combine these like terms, make it a little bit smaller, little easier to work with. So we have a like term of -4 and +1, which is going to combine to be a -3. We have a 7x and a 2x, which are going to combine to be 9x. I'm going to get rid of the 3. If you notice, both the 3's cancel out. I'm going to get rid of the 9x. And if you notice, again, both of them cancel out. So we have nothing left. We don't have an x. So when the x is gone, we look at what's left. And we decide, is this statement a true statement or a false statement? So is 0 less than or equal to 0? Well, because 0 is equal to 0, this is a true statement. And when we have a true statement, that means our solution is all real numbers. So what does that look like on a number line? It means we don't really have a boundary point, but we are going in both directions. So we have a line with 2 arrows on either end. So when everything cancels out, there's no x's left. We're going to see, well, is this statement true or false? If it is true, our solution is going to be all real numbers. Let's give another one a try. So I want you to pause the video, solve your inequality, graph it, come back and check. So first thing we want to do is distribute that -3. I hope you remembered to distribute the negative. So then we have a -3x plus 1. Combine the like terms, 2 and 1. Gonna move this x to the other side by subtracting. And then get rid of that 3. And now we're going to divide. And did you catch it? We're dividing by a negative again. So when we do that, we've got to flip the sign. It's now no longer greater than or equal to, it's less than or equal to. And -10 divided by -4 is a positive 2.5. So let's graph it on a number line. Okay, so we have our boundary point at 2.5. It's equal to, so we want to do a closed circle. And our arrow is going to the left. Because x is less than or equal to 2.5. We have one more that we want to look at. So if we solve this one for y this time, I'm going to get rid of 1. Get rid of the 3y. And I get a solution where the x's are gone again. However, this time it's a little bit different. What's different than the first one? The first one had this equal to underneath. This one does not. So this just says, is 0 less than 0? Well, 0 isn't less than 0. 0 is equal to 0. So because this is a false statement, 0 is not less than 0, we would say it's a no solution. So if we have a number line, we're just going to leave it blank. It means none of the numbers on here are going to work as an answer. So we can't draw anything on our number line. So those are just a couple new ones that I wanted to go through today. And I also wanted to go through writing some inequalities. So we have some word problems. So our first topic is the United Nations, and at the end of the chapter, you will have the responsibility of representing a country at a special meeting of the United Nations. To prepare, we're going to start by writing and solving an equation. So because it says equation, we're going to use an equal to sign, not an inequality. So we have Turkey has a population of 66 million people, and it is made up of almost entirely two ethnic groups, Turks and Kurds. There are 4 times more Turks than Kurds. Write an equation or system of equations and solve it to find how many Turks and Kurds live in Turkey. So I want you to take a minute to try to figure out what your 2 equations are. So pause the video, come back when you think you have them. So our first equation is dealing with the 66 million people. So I'm going to say T for Turks and K for Kurds. And that 66 million people is made up of Turks and Kurds. So there's our first equation. The 66 million is a total, which makes up Turks and Kurds. The second part we have right here, there are 4 times more Turks than Kurds. So that means we have more Turks than we do Kurds. So if we say T, well, we have 4 times more, which is a 4 times K. So now that you've checked your equation or you fixed it if you got it wrong, now I want you to solve this system of equations. So pause the video again, go through your steps to find out how many Turks there are and how many Kurds there are. And when you're done, come back and check your answer. So the method I want to use is substitution. Because we have T equals, we can substitute T in for T. Well, T is equal to 4K, so I'm going to change this T to 4K. So we have 66 equals 4K plus K. Combine our like terms. And then solve for K. So we have 13.2, but what does that mean? 13.2 million Kurds. And because there are 4 times more Turks than there are Kurds, we can take the number of Kurds, times it by 4, and figure out that we have 52.8 million Turks. So there's our population of Turkey. 52.8 million Turks and 13.2 million Kurds. So we have one more that I want to go through today, talking about some trees. So in 1912, Japan gave the United States several thousand flowering cherry trees as a symbol of friendship. Similarly, the nation of Cameroon plans to give flowering sada trees to other countries this year. When asked how to decide which sada trees make good gifts, Cameroon's chief arborist explained, "We plant sada trees when they are 6 centimeters tall, and they grow 9 centimeters every year. The trees only flower when they are taller than 150 centimeters." So I want you to take a minute and think about this. Are we going to use an equation or an inequality in this situation? Are we looking for one specific answer, or are there multiple answers? So if you need a minute, pause the video and we'll continue talking about it. So in this case, we just need the tree to be taller than 150 centimeters. It can be 151, it can be 157, it can be 172. Because we aren't looking for one specific height, we want to use an inequality. So, can we set up and solve a mathematical sentence, or now we can change the sentence to inequality, because we decided that we're writing an inequality to determine how old the trees can be so that they flower this year. Well, if we are growing a constant 9 centimeters every year and a starting point of 6, it's kind of like our mx plus b, if you remember. So we're growing 9 centimeters every year, and they need to be 6 centimeters tall. The trees only flower when they are taller than 150 centimeters. So 150 centimeters is the height. So now we need to decide which direction is our inequality going. So the way I think about this, I think about which one is going to be the max. So if you remember your alligators, which side is our alligator going to eat? So is 150 the tallest it can be? Or is the height the tallest it can be, the 9y plus 6? Well, because we want to be taller than 150, 150 is actually our minimum. So we want to go the other direction. We also need to think about, can it equal 150? Do we add a line under here or not? Well, the trees only flower when they are taller than 150. It says nothing about taller than or equal to 150. So we have no equal to sign. So now we have our inequality, we can solve it and figure out how old the tree needs to be in order to bloom. So it's y is greater than 16 years. So that means what? The tree needs to be older than 16 years. So that means it could be like 16 years and a month, or 16 years and 2 months. So because y is greater than 16, we need something to be more than 16. It can't be 16 because there's no equal to here. It's got to be more than 16 years old. So if I'm not back by now, I want you to get started on your homework. And if you have any questions later today, just come find me. Otherwise, happy Thursday and have a wonderful weekend. Bye.